Hello. Today we are going to start a new chapter, chapter 7, about the sampling distribution. So this chapter will be relatively short, but it's still very important. I just contain the most important informations about the sampling distributions, and it will be used for the later chapters, which are more important. So this you can think this chapter as the first chapter of statistical inference methods. So from chapter 8 and later, we are going to learn many methods to infer about some parameters statistically. And basically, statistical inference is to estimate or to guess some parameters of interest from the given data. So before learning about the properties of statistical inference methods, we first need to understand how the data were generated from the parameters. And we need to understand how the data behave or data are distributed conditional on the parameters. So what we have in practice is the data, and what we want to know is the parameters in the end in practice. But theoretically, theoretically the data are generated from the parameters. Given the parameters, as you learned in binomial distributions and the normal distribution chapters, uh, the parameters, like say, the parameters are given first, and then the Mother Nature or God generated the data, or someone randomizes the experiments, and we observe the data. So this chapter is to make a bridge between these two, statistical inference and how the data are generated. Textbook chapters, the sampling distribution is discussed in these chapters in the textbooks. And let me start with a simple question, very simple question. Suppose that a random variable x is a randomly chosen person's annual income. So you randomly choose a person and ask her or his income, annual income last year, and x is the random variable. So, and I will assume that x follows a normal distribution with parameters mu and sigma squared. Mean equals the mu, and the variance equals sigma squared. So when we say this sentence, what is random in this structure? We first have to think about what is the randomness, what is random. It's easy. The answer is x. The answer is x. Only x is random in this mathematical expression because as we defined in chapter 1, there must be an experiment. In this example, the experiment is to choose a random person. So you randomly choose a person and then ask the annual income. That is one experiment. And we say x, the result is random because x may take different values if you chose a different person. So, so if you repeat the experiment, then it will be different. Like the result will be different. So that's basically what the randomness means. For something to be random, it has to be like this. It can be different when you repeat experiments. But mu and sigma squared are common to everyone. It's it's not a result of an experiment. It's the parameters. They are the parameters. The mean is literally the average annual income of everyone, and the sigma squared is the variance across them. So it's not something realizes from an experiment, or It's not different across people. So they are the parameters, which is not random, right? I hope you to understand what's random and what is not. It's intuitive. It's even actually harder to explain or define what is random and what is not, but still it's, I think, intuitively understood. Anyhow, when something is random, when something is random, and all of the objects we considered so far were random, and then we could define the probability distribution. We could define a cumulative distribution or like conditional distribution, and then we could calculate the mean, the variance, the standard deviation, or like percentiles, median, whatever. So whenever, like, if there is a random object, then you could proceed uh, with the methods that we learned: probability, mean, variance. This is straightforward, nothing new. There is no theory. It's not a theory. Then now let's change the example a little bit. Now it's not. Now it is a research center. A research center conducted a survey of 1,000 people, right? And it asked their annual income and calculated the average annual income of the surveyed people. So X bar, we are going to denote the average as the X bar. X bar is the average annual income calculated from the survey of 1,000 people's annual income. And then in this scenario, do you think X bar is random? It is a little bit more tricky than the previous question. And I want you to think about what is the underlying experiment if it's random. And if it's not random, then certainly it's a survey, and why it's not a random. So think about this question, and I'm going to continue the next video by answering this question. See you in the next video.